All right, today we are going to take a look at the relationship between the independent and dependent variable when it's displayed on a graph, and what story a rising graph, level graph, and a falling graph, or a combination of those three things, would tell about that relationship. More importantly, we're going to look at what a graph tells us about that relationship, or what that story is. So, on page 47 in your textbook, it starts with these two things. So the first part of a graph that we need to determine are the variables. There's an independent and a dependent variable. Remember that the independent variable comes from the x-axis, and the dependent variable is along the y-axis. And so we have to first off decide which one is which. Does one of the values depend upon the value of the other? And if so, that variable is our dependent variable. Okay, and then the next thing we look at is, does the shape of the graph say anything about the relationship between the variables? All right, so we're going to take a look at these two graphs on page 47. All right, and both of these graphs show a parking lot at a school during the school day. And so we can determine a lot from these two graphs. First off, what would be the two variables? All right, so the variables for this graph over a day, obviously the dependent variable of number of cars in a parking lot is going to be number of cars, and our independent variable is going to be time. Okay, and for graph 2, the same thing applies. Number of cars is going to be what changes throughout the day, and time is going to be our independent variable. So the number of cars will change in our parking lot depending upon the amount of time. So let's take a look at the three bulleted questions. Describe the story that each graph tells about the school parking lot. So let's go up here and let's pick a pin. All right, so graph 1. Graph 1. What does graph 1, what story could it tell? Well, notice how it starts off here in the morning. This is probably morning. This would be AM. This is going to be PM, okay, because that's how the day progresses from morning to afternoon. But let's look. We've got hardly any cars in the morning, and then there's a slow progression increasing, and it kind of levels off, and then we have this high increase of a number of cars. Okay, it peaks probably mid-morning or middle of the day, and then it decreases rapidly, and then hardly any at all, and then it tailors off. So we have low number of cars in the morning, a peak of cars, peak number of cars around noon. We can safely assume that that was probably around noon. And then it goes back to a low number in the afternoon. Okay, now if I had to guess, I would probably say that graph 1 represents probably an elementary school. Okay, and the reason why is because there's not a lot of cars coming and going from an elementary school. Maybe even a middle school, but probably not, because the number of cars at noon would indicate that there would be a lot of traffic at noon, which is indicative of a kindergarten class being dismissed at noon, and then parents coming to drop off afternoon kindergarten classes. So we would also expect maybe a higher influx of cars in the morning and a higher influx of cars in the afternoon, but that could be because those are bus and AM, PM kindergartners would ride the bus to school in the morning but be picked up at by their parents, and again be dropped off by their parents but then ride the bus home in the afternoon. All right, so let's take a look at graph number 2. Graph number 2, okay, we notice that the low number of cars in the AM, okay, steady throughout the day. Okay, so we have a low number in the AM, and it increases and then it just stays the same throughout the day. It just plateaus. That would be a plateau right there. Now I realize that that is a geographical feature, but we can also use that to describe that shape in our graph. Okay, and then it decreases again at night back down to that low number in the afternoon. Okay, now again, I would probably say this is going to be probably not an elementary school, but probably more like a middle or a high school situation. Middle, junior high, high school situation, where there's going to be lots of people showing up. The cars are going to stay in the parking lot throughout the day, and then they're going to decrease in the afternoon where people are leaving and not coming back. Now, that's a typical day. We're not taking into account that there might be athletic events going on or a special event after school or before school, things like that. All right, so another label that we would need to include on here would be a title, okay? So we need to make sure that we would include a title on both of these. Other than that, these would be two different stories that we could depict from just these two graphs. Now, does that mean that graph number 1 describes an elementary school? No. We could actually make a case that graph number 1 could describe a middle school. We could make the case that graph number 2 actually describes an elementary school. The point being that we could make an argument logically about either graph for a school and why each graph could fit the number of cars in a parking lot over time. So in class tomorrow, we're going to have 6 different graphs, and we're going to have 6 different situations, and you are going to have to think about why the graph matches the situation.